Hello, good morning, everybody. Thank you for joining this webinar today. My name is Maarten Wings. I'm MKR for the EMEA region, and today my colleague is joining me, Jan-Pieter Smolders. And since after the boost, many people actually came new to Business Unit Com. We decided that we wanted to do a series of webinars, which is addressing the PA basics for colleagues who already know this and simply want to refresh their knowledge, or maybe for new colleagues which are now coming to PA and would like to understand the basics of this business domain. So yeah, today Jan-Pieter, application engineer in Eindhoven, will do the presentation. Thank you very much, Jan-Pieter. I'm personally also looking forward to this. And I give the word to you now to educate us on 100-volt system principle for public address and voice alarm systems.
Okay, thank you very much, Maarten. Welcome to everybody, also from my side. Well, this is then the first webinar of a series of webinars, like Maarten already told you. And this is the subject of this webinar is 100-volt audio systems. What we're going to talk about is how a 100-volt loudspeaker line amplifiers, and loudspeakers, how they work. And the topics will be low impedance, so the impedance of a loudspeaker, how to connect multiple loudspeakers, high impedance loudspeakers, that's the 100-volt loudspeakers. We will do some calculations and talk about the advantages of a 100-volt system. So 100-volt basics. If you look at the impedance of a loudspeaker, it is actually the resistance that a loudspeaker has to the current that a amplifier can deliver to that loudspeaker. So that means the higher the impedance, the higher the resistance is actually. Now the output of an amplifier, the audio signal that comes out of it, is alternating. It's not direct like from a battery. That's why we do not call this resistance, but we call it impedance. But it's also measured in ohms, so it's the same as in resistance. Now, another thing that is different if you compare impedance with resistance is that the impedance will change over frequency. If you look at on the right here, on the right side, you will see a frequency chart of the frequency response of a loudspeaker, and also the impedance of that loudspeaker. Here on the bottom is the frequency. You can see you go from 0 to 20,000 hertz. And here this graph is the actual impedance that is measured. And here's the lowest value. So you can see here on this scale, lowest value is around 8 ohm in this case. The manufacturer of a loudspeaker in that data sheet, they will state the nominal impedance, like you see here on the right side. Now, what does that mean? The nominal impedance is an average of the lowest value of that speaker impedance. Like we have seen in the previous sheet, the impedance of a loudspeaker changes, so it's not the same at all frequencies. So they take the average of the lowest values of that speaker. Most common loudspeaker impedances that you will see is 4, 6, 8, or 16 ohm, and they are referred to as low impedance. So they're quite low actually. Or low Z, and Z is actually the letter they use for impedance. Where they use the letter R for resistance, they use the letter Z for impedance. The low impedance loudspeakers are quite commonly used in home systems. Most likely you have at home an audio system with loudspeakers, which are low impedance, which is quite common. But they also use it in pro sound, like for instance in concert halls and theaters and festivals and stuff like that. You see large stacks of amplifiers with low impedance loudspeakers connected to it. In general, these loudspeakers are connected. So a low impedance loudspeaker is connected to a single amplifier channel. So each amplifier channel has one loudspeaker connected to it, like you see in this picture here. And that means that the load of each amplifier channel, or zone in this case, if you look at the picture, is 8 ohm. Now, if you know the power and the impedance, you can calculate the voltage that is on the outside that this amplifier has with this formula here. P stands for power, U stands for voltage, and Z we have seen already is impedance. So if we know that this amplifier is 120 watt and the connected loudspeaker is 8 ohm, which you can, by the way, also see on the back of the amplifier. That is mostly there. You can calculate what the voltage is on the output. So in this case, the voltage on the output is 31 volt, right? If you calculate this. Now, what happens if we connect more than one loudspeaker to a single amplifier channel? Now you have to be careful because now the impedance is not the same anymore. It's not 8 ohm. And how can you calculate this? If all these speakers have the same impedance, so if you connect multiple loudspeakers to a single amplifier channel and they all have the same impedance, you can calculate this with this equation here. The loudspeaker impedance of the loudspeakers that you're using divided by the number of loudspeakers. So in this case, if you have connected 2 loudspeakers to a single amplifier channel, the connected load to this amplifier channel is then 8 divided by 2, which means it's 4 ohm per amplifier channel here. And then you can also calculate the power that it consumes, because now you have a different impedance connected to it. Same equation. We type in 31 volts squared divided by 4, and now you see that the load on this amplifier is 240 watt. So basically what we are doing now is overloading this amplifier. So be careful there. If you add multiple low impedance loudspeakers to a single amplifier channel, be careful and calculate what the exact impedance is that you connect to this channel, right? So keep that in mind. It gets even worse if you have multiple loudspeakers. They can also have different impedances. How can you calculate that then? There is a equation like this. You see here on top, the first loudspeaker impedance is 4 ohm, the second one is 6 ohm, and the third one is 8 ohm. And if we fill that in this equation, we can calculate the total impedance by adding this all up. And then you will see that the total impedance of these 3 loudspeakers on one single amplifier channel is 1.85 ohm. So it's even worse. It's getting lower. That means the load on this amplifier now has increased even more. If we calculate the power that is connected, you can see that now those 3 loudspeakers will put a load of 520 watt on this amplifier. So again, be really careful if you are connecting low impedance loudspeakers to a amplifier channel. Basically, the rule is that you will have to match, the loudspeaker will have to match the output of the amplifier. So if it's stated on the output of the amplifier that it can connect 8 ohm, make sure that your loudspeaker load is also 8 ohm. Now, can we solve this issue of this load, this overload actually with serial wiring? Because now if you have 2 loudspeakers in series, you can add it up. You can add the total impedance up. So now the the impedance per amplifier channel is 8 plus 8 is 16 ohm. You can do that. It is possible, but what happens now is that you will lose the actual power that the amplifier can deliver, because the impedance is too high now. There's too much resistance connected to this amplifier. So this amplifier will not be able to deliver the full current that is required for 120 watt. So now you will have, as a result, in total 60 watt. We divide it over 2 loudspeakers. That means that each loudspeaker can now deliver only 30 watt. So the efficiency of this loudspeaker and connections to this amplifier goes down drastically. So this is also not a really good solution. You have to be really careful also here what exactly you are doing, because now you will have less power than the amplifier is actually made for. If you look at the disadvantages of such a system, a low impedance loudspeaker, yeah, well, because of the higher currents, it's a low voltage, so the currents are high. You need thick loudspeaker cables. The lower the impedance is, the higher the currents will go. So you will have cable losses. So the thicker the cables should actually be. Also, the longer the cables is, if you have a large hall or a large room or a large building, you need long loudspeaker cables. You will suffer from these losses as well. Yeah, like I said, you must make sure that the impedance of your loudspeakers will match the impedance of the amplifier, what it's made for. You have to calculate all this. You have to make a calculation of all the loudspeakers that you have connected, either in series or in parallel. So you have to be really aware of what you're doing here. Yeah, it's difficult to install. You can see you have on the right side here a picture of low impedance loudspeakers connected. You need a lot of wiring, because you cannot just connect all loudspeakers with one wire to that amplifier, because of the reasons we just talked about. So what can we do? We have also another option here, and that is a constant output voltage of the amplifier. So amplifiers that deliver 100 volt systems, that means that the output of the amplifier is always 100 volt, regardless of the total power it can deliver. It always delivers 100 volt at the output. Now, how does that work? Basically, it's the same amplifier as we have seen in the previous examples. With the low impedance loudspeakers, it's the same amplifier which delivers 31 volt at the output. But what we have done here, we have added a transformer just behind the amplifier. So that's inside the device. You will find, if you open it up, you will find a big a transformer inside, which will transform the voltage up from 31 volt to 100 volt. So that's what we call a step-up transformer. So that the transformer inside the amplifier will transform the 31 volt up to 100 volt. And there we have the 100 volt loudspeaker line. Now, in order to be able to connect loudspeakers to this 100 volt amplifier, we also need transformers inside the loudspeakers itself to transform the 100 volt back down to the required voltage of that loudspeaker. So you see here in this example, we have 2 loudspeakers connected, and in the pictures above, you will see there's a small transformer inside this loudspeaker, and that transformer will transform the 100 volt down to the required voltage of a loudspeaker. You can see in the picture as well that you can have different wattage, so the power consumption of those loudspeakers is not the same. The the voltage that is transformed down is different as well. If you look closely, the first 6-watt loudspeaker needs a voltage of 7 volts, and the second one of 10 watt will require a voltage of 9 volt. So that is what basically the 100 volt system does. If you look also at the 100 volt side of these transformers, those impedances are higher compared to the impedance of the actual driver itself on the secondary side, on the side where the loudspeaker itself is connected. Now that's why we call this also high impedance, high Z. Instead of low Z, we call this high impedance. It's also known as 70 volt or 100 volt systems, constant voltage or distributed systems. It's all the same thing. If you hear those terminology, it's talking about the same things. One thing about 70 volt, 70 volt is mainly used in the US. There they consider 100 volt as not safe, and basically that is true. If you have a 100 volt system and you run it at full power, and you have, let's say, for instance, a slow whoop on it, or an alarm signal, something like that, and you touch those terminals of that amplifier or that loudspeaker, you might get some problems with your heart rhythm, and you can suffer from that a lot. So be careful if you're working with 100 volt lines. Be careful not to touch it. Then in the example, if you look closely here below, there the 70 volt. If you some amplifiers will have a 70 volt connection to it. That means that on the primary side of the transformer inside this loudspeaker will have, instead of 100 volt, will have 70 volt. That means also that on the secondary side, where the loudspeaker itself is connected, the voltage also goes down. Now you can make a calculation here, and that's easily to see. On the first one, that was a 6-watt loudspeaker, which had 7 volt transformed down, will have now 4.9 volt. That means that this loudspeaker can now deliver a maximum of 3 watts. You can calculate that. If you use the power calculation, power equals the voltage squared divided by the impedance, you will have, you'll note that it's 3 watt. And for the 10 watt loudspeaker, you will have 6.3 volt. And that means that the power that is left for that loudspeaker is only 5 watts. So you can see, if you connect a 100 volt loudspeaker to a 70 volt output of an amplifier, you will have half of the power left of this loudspeaker. So be aware of that. It's also important to know, because then also the sound pressure level of those loudspeakers connected at 70 volt will be 3 dB less. Half the power means that you will lose 3 dB in sound pressure level as well. So keep that also in mind. Now, how do you calculate all this? It's basically the same as with a low impedance loudspeaker. Use the same equation. The impedance is then the voltage, which is 100 volts squared, divided by the power, right? If you transform this equation, and there you'll see that this 6-watt loudspeaker will have an impedance of 1667 ohm. So if you see one of those high impedances, it's really common. This is a 6-watt loudspeaker. And for a 10-watt loudspeaker, the impedance will be then 1000 ohm. In total, if you have to calculate this, you will have to use this equation if you want to calculate it. Now, the result of this, these two loudspeakers connected here, the impedance is 625 ohm. So that's a fairly easy calculation. Now we know that if we have this amplifier, this amplifier can deliver 120 watts. So what can we then connect to this amplifier? What can be the maximum impedance of all loudspeakers connected together? If you calculate that, what can be the maximum? So 120 watt can have a load of 83 ohms. So the maximum impedance connected to this 120 watt loudspeaker at 100 volt will be 83 ohm. But there's an easier way, because yeah, you don't really need to calculate all this. You can just add the power of the loudspeakers. So if you know what the power consumption of a loudspeaker is at 100 volt, by means of the data sheet or the specifications, you can just add them all up, and then you will see what the actual load of these loudspeakers to this 100 volt amplifier is. In this case, we have a 6 watt and a 10 watt loudspeaker connected. That means the total load is 16 watt. So we're fairly below the maximum power that this amplifier can deliver. So you get to go with this these two loudspeakers connected. Yeah, in order to match the loudspeaker, loudspeakers with the load, the maximum load to this amplifier, you can just add all the power up from the loudspeaker. So for instance, for this 120 watt amplifier, and you have 10 watt loudspeakers, you could connect a maximum of 12 of these 10 watt loudspeakers to this 100 volt amplifier. If you do not know the specifications of your loudspeakers, if you're an installer and you will have to change an amplifier or something, you have to do something on the existing loudspeakers, on the loudspeakers that are already connected in the building. You can also measure this. There are measuring devices like you see here, the NTI on the right side. It's just a handheld device. Then you can connect that device to the loudspeaker line. You disconnect it from the amplifier and connect it to this measurement device, and then the measuring is done with a 1000 hertz test signal, and then the actual NTI, this device will calculate the total impedance, and sometimes you also see the total power that it consumes. So that is easy. You know then if you have a 625, if you measure the 625 ohm on this loudspeaker line, you can use the same equations, the power calculations. Just yeah, you know that it's 100 volt squared divided by this 625 ohm. Then you know it's 16 watt connected to this loudspeaker line. So that's really convenient. You can do this. Yeah, if you have an existing building, you don't know what the actual load is. Just use a measurement device like this. There's another thing with those transformers. The transformers sometimes have, well, in most cases, all of our loudspeakers will have this. If you look at the transformer, you can see some taps. If you look on the right side on this picture here, you can see some taps, some outputs on the secondary side of this transformer, and that means that you can tap it down in power. So each tap that you will go down, the power that this loudspeaker will consume will be reduced with 50%, so half the power. Now in this case, if you look at the picture, we have a 6 watt loudspeaker. It has 4 watts, 4 taps. It goes from 6 watt to 3 watt, from 3 watt to 1.5, and 1.5 to 0.75 watt. And the only thing that happens then, if you look at the table above, that the step down voltage will just be reduced, right? It will go from 7 volt to 4.9 to 3.5 to 2.5. So there's a way, if you have an overload of loudspeakers connected to an amplifier channel, you could decide to to tap some of the loudspeakers down to a lower value. But be aware, if you reduce the power of a loudspeaker with 50%, if so have the power of a loudspeaker, that means that you will reduce the sound pressure level that will come out of this loudspeaker also with 3 dB. So then you have to be aware if it's a loudspeaker that is connected in a voice evacuation system, for instance. You must make sure that the sound pressure level that is inside the room is still okay, and that you have enough sound pressure level left. So what is the advantage? Yeah, the 100-volt systems will have a higher voltage, 100 volt compared to 31 volt. It's a higher voltage. The higher the voltage is, the lower the current through the cables will be. So that means that the cables could be thinner. You have less losses in these cables. You can have longer cable runs. So for big buildings, that's really an advantage. You can have multiple loudspeakers on one loudspeaker line, like you see here on the right. It's very simple and compared to the previous one with the low impedance connections, where you had to have all these loudspeaker cables to one or two loudspeakers. Now with 100 volt, you can put every loudspeaker just on the same loudspeaker line, just in parallel. You can see there's one big line here, those ceiling speakers here. It goes from the amplifier up to the last one. And you can even add loudspeakers later on to the same loudspeaker line. You don't have to make any calculations. The only thing that you will have to know is the amount of power that is connected to this amplifier. So the total loudspeaker load, that you don't exceed the maximum power that this amplifier can deliver. Yeah, you can also mix the power levels of these loudspeakers. If let's say you have the 6-watt loudspeakers connected here, and you want to add a loudspeaker later on, you can easily use a 10-watt or 15-watt loudspeaker. It doesn't matter. So yeah, it's easily to calculate. It's just adding it all up, or make a measurement of the total power that is connected compared to a low impedance loudspeaker. This is really easy. Easy to install and expand, like I just said. So the installation costs are quite low compared to a low impedance installation. Okay, well, this is basically it. Are there any questions, Maarten?
Oh, yeah, there are some questions. We can go through them now. I don't know, shall I unmute participants? Maybe if they're let me just do.
That's fine with me. If everybody talks in sequence and not all at the same time.
Oh, I already hear some.
Yeah, you have some feedback. Somebody is having.
Yeah.
Okay, Maarten, I don't think it's a very good idea. We get a lot of sound now. Maybe we can just talk.
Yeah, I just
answer the questions.
I just muted them. Okay, good. First question. What about EN54 and LS installation? Question. What is meant with what about EN54 and LS installation? What is LS? Do you know this, Peter?
I don't know. It's loudspeaker installation. Well, EN54-16 is actually the product standard that EN54 has, not an installation on. So EN54, sorry, 24 for loudspeakers is only describing the actual performance of the loudspeaker. Like for instance, the frequency response of a loudspeaker has to have a certain value between 500 hertz and 8000 hertz, something like that. But that it's not, EN54 does not subscribe or defines something regarding the installation of loudspeakers. So yeah, I don't know what exactly you want to know about it.
Okay, if there is anything, please post it in the chat.
Yeah. Let me put it this way: if you see an EM54 certified loudspeaker, then the product, the loudspeaker, is certified for it. Yeah, it's nothing to do with the installation.
Okay, then can you use multiple runs into one input on the amp? I think that's
The input of an amp.
yeah. I think
Uh,
yeah. I think
uh,
what is maybe meant here is if you can combine multiple speaker lines on one output. I don't know if this is what
yeah.
is meant.
Yeah, if you have a 100-volt amplifier output, you can also connect multiple wires to that output. It doesn't matter where you connect the loudspeakers. You can connect them in parallel. So by doing that, if you have, let's say, 2 or 3 cables coming out of an amplifier, that means that they are connected in parallel, right? So you can do that. That's no problem. The only problem you will have most likely is the thick cables. If you have 3 cables connected to one Euroblock or Phoenix connector, that will be difficult, I think.
So it does not need to be one cable run. You can have a few of them directly on the amplifier as long as it fits in the connectors.
Theoretically, you can do that, yes.
Okay. The 100 voltage system, are there no disadvantages in terms of sound quality compared to the low impedance approach?
Yeah, there is some differences. Take into account everything that you put inside of a signal path will have distortion, right? It will add something to it, either noise or whatever. Well, in this case, you will put a transformer in between, and a transformer has also losses, right? It has losses inside, especially in low frequencies where the transformer gets saturated. It will not be able to transform anymore. So yeah, it also depends on the quality of the transformers that you use and the material. So yeah, there is some losses always. So yeah, if you want to have the best sound, with less distortion, or yeah, the best performance, so to speak, then you would use the low impedance outputs. Don't use then if you have the option. Don't use the
Yeah.
100-volt outputs. Yeah.
Yeah, here is a question which relates to it. What is the key reason why a low impedance is preferred in pro sound theaters and these type of applications?
Yeah. Yeah, well, you have to take in account the transformers are also quite expensive, of course. You will have to add something to an amplifier and to a loudspeaker. So, well, basically you don't want that, right? You want as less things or yeah things inside of the audio chain.
But if I understand it also correctly, the transformer is also cutting off some of the frequency range, right? So the sound will be less full, if I can say it like that, or less colorful.
Yeah, it depends, because yeah, you have to keep in mind the current will go through a coil to a transformer. If you have a very good transformer, then it's there. Yeah, you'll have let's say what's coming in is coming out, but you have also losses, right? You have losses in the material of the transformer itself. So yeah, that's true.
Okay. So what happens if the secondary side of the transformer, of a step-down transformer, is short-circuited?
Yeah, then then you will have a very high load on your transformer. So then the 100 volt will have, yeah, okay, you will have to transform 100 volt to something that's on the other side is short, so it will not be able. So you will notice that the current through the loudspeaker lines will go up, and you will get a fault. You will get you'll in the voice alarm system you will get a fault notification if this is supervised.
But it doesn't blow up the amplifier channel or anything like that, like
Yeah,
would
well, most
Mhm.
amplifiers are protected either by temperature or by current. So yeah, they will either or they will switch off, or they will reduce the output power.
Mhm. Okay. Then there was a question on this 85 ohm that you showed on slide number 15 compared to the 600 and something ohms. The question was, this 85 ohm, is this the maximum or the minimum impedance that you can connect? Because the 600 ohms is obviously
Yeah,
more than the 85.
yeah, but 85 ohm is yeah, the lowest impedance actually. So if you look at it that way, the minimum.
Yeah,
But the lower the impedance it will be, the higher the load, right? So yeah,
yeah,
it's you cannot go lower than 85 ohm.
because then the current becomes too big in the system, right?
Exactly. Yeah, yeah.
Mhm. Okay, now let me see. Slide 14, do we not have dedicated 70-volt loudspeakers for the US market?
Not that I know of. No. No. But we have some loudspeakers that you can switch to 70 volt maximum power. So yeah, we have some. I think the LB2s, the cabinet loudspeakers, will have such a switch. That you will see next to the 100 volt also 70 volt scale, and then you can switch it one position further. So then you will have the full power also at 70 volt.
Mm-hmm.
So there are some that have that, yeah.
Okay, and then can a standard 100-volt loudspeaker be used as a low impedance by disconnecting the transformer?
Yeah, you can do that. Yeah, if you take out the transformer, you have a normal low impedance loudspeaker. Yeah,
Hmm?
it's the same.
Okay. Then there are a few questions whether we share the video. Yes, we do. So after the webinar, there will be to the participants an email with the link to the video and also the slides attached. And usually it takes us a few days to organize this and to also download the video and everything. So that will be coming in a few days from now. Let me see. I think that's it. Those were the questions. Let me see if there was a new question in the bottom, because I was going the last one to the see. Not question on the. Here is another one. Okay. What happens when the power of the speaker on a line is too much for the amplifier?
Yeah, that depends on the amplifier. If you have a cheap amplifier, the amplifier just will burn out because the current will get so high, it gets too hot and it will burn. Yeah, if you have a quality amplifier, it will. Sometimes it can last for a longer time, but then you have a thermal protection for the temperature. You can also have amplifiers that will reduce automatically the output power. So they say, okay, if there is too much load, I will reduce the current, the output current, so the power that will be consumed, or it will shut down. It can also say, there's too much load on this channel. I will switch it off.
Okay. Another one, do you have frequency response of the transformers used by Bosch?
Well, that's actually the measurements that are done are actually done with the transformers inside, right? So the frequency response of a loudspeaker that you will see in the data sheet is done with the 100 volt transformers inside. So that's where you have the result.
Mhm. Okay. How can I verify an installation is okay in all cabling routing up to the last speaker? Or maybe there is an open circuit in a determined point. Is there any troubleshooting method to detect where and localize the cable cut?
Yeah, if you only have loudspeakers connected to a loudspeaker line, there is, yeah, if you have an open circuit somewhere, yeah, the only thing you can do is put a signal on the loudspeakers and listen. So you walk to the venue and listen where it stops. If you have a short, then it will be very difficult because you will, yeah, you most likely will have no audio on the lines because it's
Yeah.
shorted. There are some ways in the voice alarm system, for instance, to look and see where a fault could be if you have, for instance, end of line boards connected to loudspeaker lines, if you have branches of lines or something like that. Yeah, we also now have the isolators for Presenza, where you can see actually which part of the loudspeaker line is disconnected on the isolators itself. So, but yeah, other than that, in a common normal loudspeaker line, you cannot see that.
Mhm. But if you have an end of line supervision board, that is only telling you that there is something wrong in the line, right? It's not telling you where there is something wrong in the line.
Exactly. Yeah. So
Yeah.
there's
Okay.
just an indication that something is wrong. And well, if you have branches, for instance, let's say you have a loudspeaker line with 3 branches, and each of those branches will have then an end of line board. Then one of these branches, the end of line board will identify a fault, right? Then you have some direction on where to look.
So you know
Other
which
than that,
board it is.
which
Yeah.
yeah, on which part of the installation it is, of the loudspeaker line
Yeah.
it is. But more than that, it's yeah, you cannot tell.
Okay. I see we're over time already, but I think let's answer a few more questions. So for low impedance, what is the impact of improper calculations? Is it damaging the speakers or the amps? Is there any protection?
Um, well, there are two things actually. If you have a loudspeaker, and the loudspeaker, let's say loudspeaker is 8 ohm, and the loudspeaker itself is designed to handle, let's say, 20 watt, and you connect a 24 watt low impedance loudspeaker to a 120 watt amplifier, and you turn the power up full, then you will blow up the loudspeaker. So that's one thing that you have to keep in mind. The power that a loudspeaker can handle must be minimal the power that an amplifier can deliver. So if you have a 120 watt amplifier, you must have a loudspeaker that can handle at least 120 watt or more. Or you have to make sure that the output, so the volume of your amplifier, does not exceed maybe the 20 watt that you will have connected, the loudspeaker that you have connected. Now on the other side, on the amplifier side, if you connect too much load to the amplifier, let's say you have an 8 ohm amplifier and you connect 4 ohm to it. Okay, that means that you will ask twice the amount of power from an amplifier. Then the current will go up. The current will go up, and at the lower output voltage, the current will
Yeah.
already be very high. So that
Yeah.
means this amplifier will get very hot. It might burn, and if you're lucky, it will switch off. It has a protection that it will switch off, but eventually you will blow up the amplifier.
Okay. A question, what about a full IP installation? Is that realistic?
Yeah,
that
IP
IP
does not
speakers.
have anything to do with impedances. Nothing to do with 100 volt. So I don't know. I don't really understand the question.
Okay, maybe the question is in terms of wiring. I don't know, but indeed, it's a completely other concept.
Yeah.
What reliable cable loss calculator can you advise? Do you have any?
Whoa, no, I don't have any calculator to calculate that. No, sorry, I don't have that. But you can what you the thing you have to do is you have to look at the specifications of your cable, and then you will have to look at the resistance of the cable, the copper that's inside, and then you will know that a cable has a resistance of some value, and then you can calculate it just like that. We have some calculation examples if you like. I can maybe send that around as well. I will send that to you, Maarten. Okay, then we can send that around.
Okay. Then another question, how to calculate the speaker for A-class wiring loop connection?
It's the same for 100 voltage. Just add it all up. Just add the power of all loudspeakers up, and then you have the maximum.
Yeah, it doesn't matter if they are connected in a loop. It doesn't change the principle of how the power is distributed.
No, no.
No. Okay. What other disadvantages 100-volt techniques might have? Open question. Anything you know?
Advantages. Yeah, the biggest
Disadvantages.
disadvantage.
Yeah.
Yeah, if you yeah, the disadvantage is that you need a transformer inside of a loudspeaker. You need a transformer inside of an amplifier. So yeah, there's a disadvantage. It's more costly. And also yeah, you'll have an additional yeah, disturbance in the signal pathway. So there are losses also in the transformers. So yeah.
Mhm. A question, can a 100-volt system be less loud than a low impedance system, or is there no difference?
No, it's no difference. You can eventually the power that a driver, the actual driver of a loudspeaker can deliver is the same. Doesn't really matter if you put a transformer in front of it or not.
Okay, as long as you step it down to the original.
Yeah, as long as you, well, you can. Okay, the transformer is determining the power of that driver. Let's say you have a 6 watt specified loudspeaker, 100-volt loudspeaker. That means that you cannot, because of the transformer will not exceed a certain voltage, output voltage. You cannot go beyond that power. While the driver maybe inside could be well able to handle 10 watts, maybe, or 12 even. So that's possible. So you could have, let's say, a driver inside that is able to handle more power than the transformer can actually. So that's possible.
So just extreme example from my understanding, if you would have a big concert in a football stadium where you have, you know, the big large speakers that are addressing the crowd, that could just as well be a 100-volt system if you would just have the right transformer inside.
Could be, yeah, could be, yeah.
Mhm. Okay. Do these in that range, does a 100-volt system approach exist, or is it always low impedance?
No, I don't think so, because if you have a fixed installation, you can yeah, you have your amplifiers installed somewhere, and your cable runs they're fixed installed. So yeah, I'm not aware of any 100-volt installations, to be honest. No.
That
But
okay.
yeah, but to be honest, I have no experience in that at all. So, but
Yeah.
I would guess there yeah, they don't use it. You have to also keep in mind that if you have large loudspeakers, you have to put them up on the ceiling and stuff like that. Those transformers inside, if you use those, they weigh a ton. They're really heavy.
Hmm. Okay. Good. I think we're already 10 minutes over time. Let me see. Do you have a simple system design calculator tool? Question. Do we have this?
Well, that's for a 100-volt loudspeaker design. It's just adding it up. It's like 1 + 1 + 1, and that's it.
Okay. Okay. Now, does amplifier blow up stand for a real explosion that can create a safety injury or fire risk?
No, with blow up, I mean it will start burning. It will get so hot that yeah, the insulation of some material will start melting, and maybe something will yeah, will start a fire or something. That could be happening. I've seen transformers, for instance, that will melt it down, and then yeah, that's how it starts most likely.
Hmm.
So it's not that it will explode or something like that. At least, yeah, I don't think so.
Yeah. Does a stadium with emergency PA systems have to use a EN 5400 volt system?
I don't know. I'm not an expert on that. I don't know.
Okay, and then can you have two systems in the same area? That question is.
Two systems
Oh,
in the same.
yeah, that's related, I think, to the 100. Maybe if you can have a 100-volt system and a low impedance system, maybe in the same area mixed. I don't know whether that is the question.
Yeah, could be if you have, let's say, if you have a bar and you have a reception or a hotel something, you have ceiling loudspeakers, which
Hmm.
are 100-volt, and on your bar you have two cabinet loudspeakers on low impedance connected. That could well be, yeah.
Okay. Good, Jan-Peter. I think we have tortured you with enough questions.
Yeah.
I think the most of them we still answered, and there are still 96 people in the meeting, so I think that was good. Yeah, everybody, I would like to close it now. Thank you all for your questions. We will send around the video recording and the slides, and we hope to see you on the next session on the basics of the PA voice alarm systems. Jan-Peter, thank you for doing the presentation. Very interesting, and looking at the questions, it seems that it's relevant content. So thank you for that. Okay, bye bye
Yep.
everybody. Have
Yeah.
a good day.
Thanks. Thanks everybody. See you next week, hopefully.